The proper response is good evening, Ricardo. Thank you everyone for showing up tonight. For those of you who have been members for Chef-NYC Meetup for a while, I apologize. As the organizer of Chef-NYC Meetup, we have not done one of these in quite some time. And after much deliberation, thought, and planning, we decided to start it up again. So first off, thank you to Dan and Michael for helping coordinate, get the word out. Dan specifically for the space. We really appreciate that. It's the hardest thing to do in the meetups is to get space with everyone around. And tonight we're going to talk about Habitat. But before that, what I'd like to do is give the mic to Dan, talk a little bit about ShopKeep. Michael, talk a little bit about Salt. And then we'll get into our content for tonight.
Thanks, Ricardo. Just to say a few words about ShopKeep, we don't tend to talk about ShopKeep much at meetups because this meetup is not about ShopKeep. This meetup is about Chef. This meetup is about you. And so ShopKeep, we are a tablet to cloud point of sale, which means we're helping small businesses, blah, blah, blah. The real important part, though, is ShopKeep is actually committed to growing the community that we live in, right? Every one of us are engineers. We learn from each other. The best way to learn is to host a meetup, go to a meetup, speak at a meetup, talk at a conference, commit to open source software. Every one of those things. And so everything that we do here is try to encourage our engineers to help their communities, both globally and locally. And I ask you guys to do the same. So if you do have meetups that you attend or speak at and need space, we'd be happy to help you with that. So thanks.
Hey guys, I would probably say it's similar to what we at Salt like to perpetuate as well, just helping the community. If you don't know who Salt is, we are a digital recruitment firm. So anything from tech to sales to marketing teams, we help grow. But at the end of the day, it is nice growing the community as well. You usually see us at different meetups, either sponsoring events or even just bringing the food and pizza. So thanks for having us, guys.
All right.
Let's switch this over. Yeah.
Magic. Let's need to hit the present button. And we'll all good. All right, terrific. So again, thank you all for joining us tonight. What we're going to go through is talk a little bit about Chef software. Who uses Chef software today? All right, good. It's more than a coin flip. I like it. And so what you typically think about Chef software is you think about configuration management, infrastructure automation. And so we've made our bones around that, built a great community around that, built a great product around that. One of the things we're seeing in the industry, as I take the, Nathan, you have to fix that whole pop-up thing when you do the present. Like, sorry. One of the things we're looking at is as the industry progresses and as technology in the industry progresses, it's progressing at a very accelerated rate. What we even thought about 5 years ago as a problem, no longer as a problem. Commoditizing infrastructure, how do we add value and business value in the things that we're delivering? So my name is Ricardo Lupo. I manage a team of solution architects. If you use Slack, I'm the pointy-haired boss emoji in there. And with me tonight is Jason Lane in the back of the room. He's one of our senior solution architects. And together we're going to talk to you a little bit about application automation, specifically with our open source project, Habitat. Now, first off, if you're a Chef user, ChefConf 2019 is going to be in beautiful, cloudy Seattle this year. It's the week before Memorial Day weekend. And so CFP is now open for ChefConf. So as Daniel mentioned, we are an open source community as well, an open source company. And so one of the things we pride ourselves on is the ability for our community members to submit talks, talk about Chef, talk about open source, talk about how you scale teams, talk about how you collaborate, right? There's the softer side of DevOps outside of the tool chains that you use. Great opportunity. If you need help crafting a permission letter from your boss, come to me. I'm very good at wordsmithing, as many parts of my role, so we can help you with that as well. When does CFP close? Well, it just opened, so. Obviously before when. Yes, so just go ahead and submit your CFP. Okay. And if you give me a quarter, I'll help accelerate it. I'm usually part of the team that helps review the CFPs. 1,600 plus attendees, a lot of people, 20 plus workshops, 35 sponsors, 72 plus breakout sessions, and one amazing week, again, this year in beautiful Seattle. CPs are open, chefcomp.chef.io, and just do it. Just go for it. We're going to extend that, but just get your CFP in now. Just get it in. All right. You'll have to give me 50 cents for that if you want to extend it. All right. So how many of you are familiar with Chef? All right. So like I mentioned before, Chef infrastructure automation. What we're going to talk to you today is about something fundamentally different. Okay? And so what we're seeing in the industry is the shift to more commoditized platforms to deliver applications. So what does that mean for you? It means shifting your focus around how you actually deliver those applications. So fundamentally with Habitat, we're changing the paradigm of the way in which you actually deliver business value. And so the idea around Habitat is we enable application teams to build, deploy, and manage any application in any environment, abstracting the way in which you build and package those applications, one singular way to do that, and allowing you to deploy those applications anywhere, whether it's traditional data centers, bare metal, to containers, microservices, even containerized services such as EKS and AKS. Everyone familiar with Amazon and Azure's Kubernetes services that they offer today? Right? Very compelling. All of that's abstracted. How do you take advantage of that in a single way and allow you to make decisions about how applications are actually run from a business perspective? So there's two patterns that we're seeing around Habitat. One, really this is the core of the value around Habitat, lifting and shifting your legacy applications to modern platforms. So one of the things we struggle with around taking our traditional data center-centric approaches and bringing them to the cloud is we're actually bearing all of that technical debt, the operating system, all the pieces underneath that, and we're actually bringing those things into the cloud as well. We actually don't want those things in the cloud, right? We actually want to take the thing that's the business value, which is the application, and really we want to abstract that from the underlying dependencies, and we'll show you that pattern in a little bit. Also, the screen time not really cooperating with me tonight. The other side of it is delivering on cloud native. We all want to be cloud native. We all want our applications to be cloud native. We want them to have things like RESTful API endpoints. We want them to have modularity and scalability. How do we deliver that as part of our application strategy? So Habitat at its core, what we do is we split the platform-independent part of the application from the platform-dependent part. And this is very, very important. So from a build perspective, we take the application, we take all the things we know about the application, we declare all of its dependencies, and only the dependencies that are required for that application to run, and we build that into what we call a heart file, or Habitat artifact. From there, we can take advantage of Habitat's underlying deployment strategies to actually deploy to any target that we wish. Again, traditional VMs, bare metal, all the way through Docker containers, through Kubernetes, et cetera, et cetera. What this does is it unburdens us from having to carry all of the debt, the technical debt, and all the heavyweight underlying OS dependencies for our applications, and allows us to freely and make decisions about how we deploy that application freely based on the business value of that application. We also give you management primitives inside of Habitat to actually manage that application in what we call a supervisor. So this allows us to do things like defer decisions about our application's tunables until runtime. So think about an application that you've built in a development environment, and you've had to declare a bunch of port numbers. As you move that application through its progressions from dev to QA to production, clearly you have other requirements that you have to keep in mind. Well, I can't run my application on port 80 in production because that's a non-approved port. I have to run it on a non-standard port. Rather than having to have your application be bundled with those dependencies early on, what I can do is actually define those as tunables, and when I deploy that application to production, I can make those decisions about how my application behaves there. The other thing I can do is I could actually expose things like RESTful API endpoints for health checks, even if my application actually doesn't support them within the Habitat supervisor. So fundamentally, how does it work? So the users of Chef, can you raise your hands again real quick here? Great. So all of you have used Chef in your careers, and most of you who probably try to solve these problems have solved them from the infrastructure perspective, which means I'm trying to build my automation starting from the operating system, moving up the stack. And so this inherently presents problems around how I actually automate ultimately my applications, because I bear all of this burden around what's running in the operating system simply because, for the most part, a lot of application developers make assumptions about what's available in the operating system. It's just a clear example here when a developer runs something in dev and it just, quote unquote, works. They're making a lot of assumptions about what is actually available to them when they're compiling and running their application, where when they move through their progressions from, again, that dev to QA to production cycle, those assumptions disappear. And so the challenge is with Chef or any sort of infrastructure-centric automation solution is, again, you're starting from that bottom up. So most people who write config management code, cookbooks, whatever you want to call it, tend to do defensive coding, right? They code for the deltas that they expect from, say, an OEM distribution of an operating system to what their, quote-unquote, corporate standard is for deploying that particular platform within their environment. And so what happens is it's defensive. So you're only actually coding for the things you're aware of. No one's ever written a chef cookbook to actually declare all of the things that they want from their operating system, because it's way too much work to do, right? And so what we want to start to do is we actually want to start to change that paradigm and go from the application down, which means I want to start with all the things I know about my application, start from there, and declare only the dependencies that are required for my application to run. So if your application doesn't need libcurl, there's no reason to actually define libcurl in your application because it's not required. So whether or not it's present on the operating system is irrelevant to you. You care about only the dependencies that are available to that application to actually run. As part of this, we provide an embedded supervisor as your management interface. So again, part of your application tunables, and Jason will demonstrate this as we go through the workshop. This is really not cooperating with me. Is the fact that you can actually declare the things that you need your application to run in, ports, endpoints, whatever it is. You can declare those as tunables and inject them at runtime, which is a really powerful primitive inside of Habitat, because it allows you to create your applications as an artifact and have that as a consistent thing all through, again, your progressions through dev, QA, and productions. And all of our packages are atomically signed, so you know exactly what you have in any build at any given time. So outside of semantic versioning, you also have atomic versioning. Again, you know exactly within that atomic timestamp what is in your application. So to illustrate the problem a little bit further, we kind of put this graph together. And so invariably, hopefully no one disagrees with this comment. I don't think you will. But ultimately, anything you run on, the business value is up here. Right? It's in that application that you're running for your customer or your end user to consume. What we do is we actually build those applications with these dependent things underneath them. So middleware stacks, operating system stacks, and whatnot. And when we build those applications with those underlying dependencies, we have to actually eat the entire burden of that entire stack, right, as we run those applications. So quick question, anybody running on an end-of-life platform? There's a Barclays, guys. I know you do. I know you do. I know you do. Right? 2003, right? Well, I'm asking the question for a reason, right? And so why do you still support those end-of-life platforms? And why is it too difficult to get off of? Because you have no idea what is actually required for that application to actually run. And so what you're doing is you're playing defense, right? And saying, hey, my job's on the line. I'm never migrating off that thing because I have no idea what is actually running on that operating system. Right. Right. And so the byproduct of all this is when you declare these things from the application perspective down, Dennis, you always bring this up, it's self-documenting, right? That habitat artifact also provides an empirical atomical declaration of what that application needs to run, and it's in code. One of the things we've prided ourselves always as Chef, as we talk about infrastructure as code, nothing beats the code. You can go on a box and go inspect and introspect about all you want to do, but the thing that wins all the time is the code. Here is no different. We're taking a different approach on how you actually automate your applications, but fundamentally what's in the code is what always wins. And this is even more important now as we start to want to take advantage of more cloud and modern types of technologies, is how do we actually run these things in a way that's abstracted from the underlying infrastructure. And so a lot of this problem really manifests itself in quote unquote legacy, which people call as stuff they don't want to look at and touch. But really, legacy, they're critical applications because you'd shut those end-of-life operating systems off if they weren't critical, right? Like, would you not? Like, I would. I mean, I don't run production systems anymore, so I can say whatever I want. But ultimately, the other side of it is if you knew you were end-of-life and you weren't supported by the vendor, would you not just shut those systems off? They're running something that's really, really critical. And so what I want is I really want to abstract this piece from these pieces. Because these pieces, while they're important, they're a means to an end, right? They're not important in and of themselves. And so one of the things we saw is we surveyed a bunch of people about this, and what we wanted to actually understand is how do we extract business value from the... I will make them available, so as long as you're registered to the Meetup group, I'll make them available. At least. It's 7 figures. I won't say $1 million because that's short-sighting it. But it's definitely a 7-figure problem.
It's as much as you're willing to pay. No, it's a little bit more.
But we will make these slides available, yes. So the question was, will we make these slides available? We absolutely will. How do we abstract these pieces, right? Because these are the bits that are really valuable from the underlying bits that support that end. And here's the other thing that's a reality, and whether or not... So I worked in financial services for about 15 years before I went on to the dark side or the light side, whichever way you want to actually describe it. And to be frank, we thought our problems were very unique. And what I've seen being on the other side is everyone's got the same problems. Everyone's fundamental, and especially in IT, everyone is solving for the same set of problems. That's okay. Well, I get to delegate. But the idea, the pressing thing here is heterogeneity is here to stay. The choices are only going to increase. They're not going to decrease, and they're going to increase exponentially. We're talking about a huge industry shift from about 5 years ago to now, where 5 years ago, all we were talking about was VMs, right? And think about what we're talking about now. Not only are we talking about containers, we're talking about containers as a service, we're talking about serverless, we're talking about functions as a service. Things are just invariably changing, and they're changing at a very accelerated rate. Why? Because this is the value. And as quickly as I can get the things that keep disappearing off my screen out to my end user, that's the thing that's important. Quick Q&A before we get into the workshop. Any questions? Yeah. It's a great question. And so hopefully we'll be able to show some of that. So the question was, how does this differ from a Docker image? And so the answer there is really, from the application's perspective, a container is just another deployment endpoint or a deployment artifact. What we're trying to do with Habitat is we're essentially trying to give you a singular interface to build and manage your applications. And we're trying to abstract the deployment target to whatever makes sense for you from a business perspective. So a container may make sense from an initial deployment perspective, but that container, you may outgrow it. You may actually want to dedicate actual resources, and you may want to do it on-premise. That should not force you to have to rewrite the entire method of which you deploy that application. What you should be able to do is make a business decision that I want to take that application, move it on premise, move it into bare metal, and simply re-export that application pattern to a package that supports your on-site, right? And so again, Docker's a great technology for essentially abstracting the bits that you need for your services to run. The other challenge we're seeing too with customers is there's potentially some ISV support, so OEM support issues, where the third-party vendor doesn't support a container, and you shouldn't limit your choices based on what a vendor might or might not support. One more question?
To add to what you said,
Oh, okay.
He mentioned earlier in the presentation of if your application doesn't need libcurl, why do you have libcurl? Who remembers Heartbleed? Please tell me I'm not the only one here who remembers Heartbleed. And so, if you want to, your application doesn't need OpenSSL, you should never have OpenSSL. And Habitat lets you build without OpenSSL never getting near your application. The other thing it really provides, and they will help show you, is heritage of it so that when another Heartbleed happens and your application does need OpenSSL, you can prove all the way up and down your management and security chain that this was built, this particular version of this application that's in production was built with a version that's patched. And so being able to prove that with Docker, having to re-roll 200, 300, 4,000 Docker images to say, hey, we need to patch OpenSSL because everyone just does from Ubuntu, yeah, that's no fun.
And that's the other thing too. Like if you think about how you actually deploy services and whatnot with Docker, that Docker file essentially is completely declarative around the thing that you're deploying for that particular container. So think about application. I've got a pattern. I might want to deploy it, let's say 10 times. The only thing that changes for me in that application is a port number and perhaps a library that I use. I'm managing 10 different Docker files. What if it's 50? What if it's 100? Right? So the idea with Habitat, we actually give you the ability to define a pattern, and then those things that are tunables, they're runtime decisions. I can defer those decisions to runtime rather than having to bake them into my Docker file really early on in the process. So while the experience is super great, you use the Docker file to define all the things, even if you don't do the from Ubuntu or the from CentOS or from whatever and eat the entire operating system distribution, which is another anti-pattern, but a lot of people adopt that because they don't want to declare their actual dependencies. The other challenge you have there is that how do I actually run my application in a portable way, which allows me to actually say, hey, the only thing that actually changes here is the port number. And so if I have 100 ports available, I don't care. That's a runtime tunable. It's a runtime decision I want to make, something that's very challenging with Docker. And so the nice part about Habitat, it gives you the ability to take advantage of that singular packaging interface and then still use Docker for the deployment. I can use Docker Compose because I've exported it into a container format. I can simply use Docker Compose to actually run and schedule that. Habitat's not a scheduler. So that's an important distinction. We don't schedule resources for things you build with Habitat. It's a very mature ecosystem. Everyone's using Kubernetes. They love it. They want to use it. We don't want to get into that business. What we give you is that consistent interface to actually manage those applications that are running in those deployment targets. One more?
Isn't the abstraction that you're describing analogous to what Java was supposed to do for operating systems, where you just compile application to a bytecode and you run it on any JVM?
Sure. The thing that we're giving you with Habitat is the consistent interface. So as an app developer, and so the question was, isn't Java analogous to what you're doing with Habitat? Because Java was the promise around Java was to give you that single interface to write an application and run it anywhere. Well, I'm going to let you be the bad guy in the room. But like the idea with Habitat, first and foremost, it's a consistent interface for developers. We use Shell. So anything Linux-based is Shell, Bash. Anything Windows-based, and we fully support Microsoft Windows with this primitive. So even though we're going to show you a Linux-based tutorial, we fully support the Windows ecosystem around this. So Windows is all PowerShell. So an app developer typically develops in either Bash PowerShell. It gives them the same interface to actually describe how their application should behave and how it should be automated as well. It's one of the biggest challenges we've seen with Chef customers. You run PowerShell or you run Bash, and then you've got to switch to Ruby, right, to actually figure out how to deploy your application. And while that context switch seems to be very minor, it actually adds some latency to the development cycles. Jason? Jason's gonna give you the other side of that answer.
So you're talking J2EE, right? My man. Absolutely. I was a WebSphere AIX admin for a long, long time, and what I loved was that freaking JVM because I didn't have to worry about the infrastructure or anything like that. So take that same paradigm and those same thought patterns around that JVM and that containerization. Yes, that is how Habitat. That's how when I first started doing Habitat. That's how I started to understand it was taken from a JVM, J2EE world of, hey, this is my runtime environment, and this is what I have. So think of the supervisor as your big long Java string, and you have all that information, all that detail in there. Absolutely. So have that. Then you have your workloads. Those are your applications running in that J2EE environment. Perfect. That's the same. It's a little bit different, obviously, from we're not doing Java code, we're not doing war files, ear files. But we can do that. We have hooks into like Maven and everything like that. You'll see in here. Actually, not in here, but if you go out to habitat.sh, you'll see that we have core plans for Java 7 and Java 8. So we'll have all of that kind of nitty-gritty detail. But that same paradigm applies to Habitat. And that's a very good place to start because that's how I started to take, because with any new technology, you kind of start with what I know from an old standpoint and what I've been working with, and then trying to translate that into something that's new and trying to say, oh, okay, this is kind of like this. So yes, I think it's like a lot like J2E or whatever they call it these days. So yes, that paradigm is certainly still applicable to what we're doing in Habitat.
Awesome.
You want me to go?
Yeah, you can just take it.
Yeah.
So, Jason Lane, everyone, he's going to take you through the workshop. If you have laptops available to you, I suggest you open them up, please. We want this to be interactive. We want these hands-on. Jason's going to take you through the tutorials that we have actually online, so you'll be able to do these after you leave. But what will be great is that when you're here with us today, you can ask questions and go through these, and ultimately hopefully get a better grasp of what Habitat actually gives you. Jason, take it away.
Thanks. All right, so everybody, so we've got a couple things here. Who's got Windows laptops? All right, so I do have a couple of Linux instances I can pass out to you all. So let me go out to my GitHub, make this public. So if you go out to Gist and search for my JM Lane, you'll go and find an application or a VM out there running in Azure.
Yes.
What was the Wi-Fi was?
Search for you, SK Meetup.
JM Lane.
Oh, you're right, just
Yeah. And I just made that public. So grab one of these IP addresses. Some of you folks, I'm sorry I didn't bring my cards with me to pass out. Someone keeps stealing my cards. Like if you ever been to any of the chef training where like they hand out playing cards and they're chef ones and stuff, someone keeps stealing them, so I can't use them anymore. But grab one, and then once you log in with user chef and the password chef. Log in, and underneath your root, just do a echo or a touch in your name, so everybody will know that this machine is being used. So first thing when you log in is just do an ls, make sure that nobody's using this machine. If they are, log out and just grab another one. I mean, I've got 30 of them here, I think, or 20 of them, so we should have plenty. And that's only for the folks that have Windows. The lab that we're going to go through is Linux-based or Mac-based. If you have a Mac, I would suggest that you do this on your Mac so you have it with you. It's not that big. It's nothing that's going to, wreck your laptop or anything of that nature. Ricardo, what'd you do to my machine, man?
So, to be clear, I didn't touch your laptop before I started doing that, so unless I have ESP, there's no way I can. Yeah, so Jason, if you have a Mac that you can install software on, go ahead and install the CAD package as well as Docker for Mac.
Yeah, we'll go through all that.
Take this as a leave behind. And if you don't, unfortunately, if you're running Windows, it's fine.
Yeah, I mean, if you don't, if nothing else, I'll go back to that in 2 seconds. Everybody else, if you do nothing else, just go out to the habitat.sh and mark that as a bookmark, because this has all the tutorials and everything that we're going to go through. And we're going to do the simplest, easiest one, but we've got other ones that are on here. And we actually do have a Windows application out there as well. So if you want to go and try this natively on Windows, you certainly can. So what I want everybody to do is to go out to GitHub and to blow this up. Go and clone this application, this repo. GitHub habitat.sh sample node app. Again, you all can follow along on this this screen. So this is our repo, and what we have here is a Habitat kind of structure, right? An application that's been habitized. So we have a couple different things that kind of belong in here, right? We've got kind of our JS files, we've got our JSON files and everything like that. But the one thing that I want to show, and the one thing that's going to be most important, again, if you don't, this is probably the second or third thing I've told you if you do nothing else, is find a place where you can put this plan.sh file. So this is what you'd consider kind of your recipe for the folks that use Chef. This is kind of the plan document that says, hey, this is how I want to define my application. And the reason why I want to show you this is a very good example and is very verbose in what it's doing as it's going through and doing this this Node.js application. It's a very simple application. It kind of tells you in the comments what this thing is doing. So this is a lot cleaner and a lot simpler than if you just started with doing, you know how you do a generate cookbook in Chef? If you did a hab, plan, and knit, it goes and does the same thing, but it puts a lot of stuff and a lot of variables and it gets very confusing in your plan.sh. So if you just did that following you know, some of the documentation, you'd get confused, where this has a really good simple plan that explains to you what you have to do to build your application. One of the things that I really found helpful for me while learning Habitat is take something that I know as an application and try and just, you know, you've got a couple hours, throw it in your backlog, just as long as you have time to go and do something. So like, I used to work at Splunk, right? So the thing that I've done to kind of help me understand Habitat is try to habitize the Splunk forwarder, because I know that application. I know how it's installed. I know all of the directories. I know all the little things, the gotchas and things that it needs to be able to go and install. I know it's going to need things like unzip. You know, I know it's going to need to have some certain C libraries to go and do an install. So my recommendation to you all is, after we kind of go through this this sample application, pick something that you know. Anything that you kind of understand really, really well, or you install manually day after day, go and find something like that and go and use this plan file in the documentation out on habitat.sh and go and start running this and kind of figuring out how this thing actually works and how it actually runs inside the supervisor, inside of that container. So that's kind of what we're going to do today. Everybody able to go out at least to habitat.sh, able to follow along there and see where the tutorial and stuff starts?
Remember, nothing's magic, right? So to Jason's point, took something he was well aware of how to do on his own, and he brought that skill set knowledge into how he's going to automate it using Habitat. So it's very important that you collaborate. So this is like the Devops spirit that we always talk about at Chef. Collaborate with people that understand that business value. You bring the knowledge around Chef, and you work together as a team to automate and be better. See, I didn't touch your laptop this time. I just spoke, so maybe it's my voice.
No, it's I'm trying to fiddle with this over here. Let me try this.
The next meetup will do earphones.
I don't know. Maybe. No, thing's been pretty solid. I can use my dongle and then another cable if you want to try that. So I've got a HDMI. Oh, a nice thing about the VMs is they have Habitat and Docker already installed on them. What's that? Oh, I wonder if the read got me. Let me log into my environment. So nothing? Nothing?
The 5 or 6 I tried.
Okay. I wonder if I got reaped. I shouldn't have gotten reaped because I put all of the detail in there. Virtual machines. Yeah. I got reaped, but I put it, so we put in, so, you know, us being lazy people at Chef, we never go and clean up our shit. They put in a Reaper script and they said, here are all the things that you have to go and to put in to make sure that your stuff doesn't get reaped. Well, guess what? That was a bunch of bullshit. Let me see if my resource groups are here. So we're going to learn a little bit about Azure today.
Anybody use Azure? Yeah.
Oh, my God. All right, well, that really sucks. I mean, I can spin some more up, but I mean, that really sucks. Fuck. All right, so I guess we're just going to have to kind of follow along with me. I apologize for that. Ricardo, I'm sure you're going to take a note of that.
I already.
Yeah, because that's... So those of us in the Mac world were okay. So I already have the, so I obviously have this up and going. So I have it here on my machine. So I download it, I get it from GitHub, and there's my sample application. And if I do an ls, here I've got it here, and if I do have version, I think it's just blue. No. Yeah, so I've got the latest version out on here. So when I'm I'm on my Mac here, if I'm in the Linux world, I don't have to do this, but I like to do it just to make sure that I know what I'm doing. So if I put a -D on here, this is me entering the clean room. So what the clean room is, it allows me to go and what it does is, this is the reason why we put Docker on our machine, is this allows me to create a anti-corruption layer to whatever I'm doing now inside of a Docker container. So I'm actually going and doing my my local development inside of Docker. Now, if I don't use the -D, I can go and I can run the supervisor and everything just natively on my machine. And this is kind of typically what I do from a standpoint of if I'm doing things in the Windows world. I usually just spin up a VM, install Hab on like on Windows 2016, and then I just go and I run Hab Studio Enter, and I just run it natively on the Windows machine.
Hey, Jason, what happens if you're on LS right now?
So if I run LS, I just go and I'm in my root directory. So this root directory kind of gets taken in from my local file system and now becomes my root.
What happens if you do tree?
What's that?
What happens if you enter tree?
Oh, yeah. So now, we were talking about how we don't want things and we do want things. This is a good example of this where I don't have tree, because why do I need tree when I'm going and putting an application out there, right? What if I do yum? I don't have that, but just to make sure that you guys do understand that I am actually running a container here. I've got Linux. I don't, I'm not seeing Debian or anything like that from my Mac. None of that stuff.
And
No.
so
No.
that perspective is really important. So the thing we talk about, the triangle, the infrastructure-centric way to do it is to basically install the entire package and all its dependencies. You now have to eat the complexity of all those dependencies in that package as part of the thing you're building, which is the application. And so while that feels like the right thing to do, it's actually the easy way out. Right? And so the idea here is that what you want, you only want to declare dependencies that you need for your app to run, and not have to eat the complexity of all of the other things that you actually don't need for your application. Even though running Node, I can have the Node package installed.
So how do you get habitat still?
No, so it's completely separate. So Chef-NYC is the chef, all the chef things you need to run chef infrastructure. So Habitat City of Finance, you can either download it from habitat.sh. We also have Brewcast repositories, so you can download it from Brewcast. I believe it's habitat-sh/hab is the namespace. You can also download it from a public, I believe you can download it
Yeah,
from
it's
repo.
yeah, you can get it from the
If you're a
repo.
Windows user, you can download it from Chocolate. So we publish our Habitat packages on Chocolate.
And there's an MSI, DMG, Homebrew, Chocolate,
Yeah.
not Mac, Homebrew, sorry. If you're on
Oh my God. All right, so I've got my my application here. So now I am running build. So what this is doing now is when I do build, it's running my plan.sh. Yeah, I don't know what's it's not my machine, but we'll get through this. So it's doing an install. Again, it's taking all the binaries, and again, this is written in Bash, right? Other than a couple of the kind of habitat-specific things like the do build, do download, all of those types of things that you know, we kind of define. This is basically written in Bash if you go and you actually look at the plan. And of course, there we've got the plan.sh, which says, I love it when a plan comes together. So now, when I go and I look and I do a ls into my results file, I have that heart file, which is exactly like what I think of as my ear file or a zip file. So that has that has everything that I need to go and run my application. And this is the thing that the supervisor actually picks up and starts running. So now, I can go and I can actually start running this, I believe. Yeah, so I've done this, I've done the build. And, oh, actually we do this. So we're talking about Docker. So now I can go and just do have package Docker results. And what this is doing now is this is actually exporting it into a Docker, you know, so we can go and run this and just do a Docker up or a Docker run.
Did you show them your plan?
I'm going to go over that in a minute. I'm going to spend a lot of time in that. If you were attempting to install from a local depot. Oh, I'm not in a... see if that'll work. Oh no, what is my... Yeah, this is... I'll take that.
Everyone see that habitat artifact is atomically timestamped. So while you also have a semantic version, so you have two different versions. Those are atomically timestamped, so they're obviously different than Jason's screen as part of this being developed.
I don't know, that usually works, but I guess because I have two heart files in there. So there I'm going and installing and verifying all of my different core files for this. And now, there we go, now it's building the image.
Anybody in the room actually built an application or compile an application? So taking a bunch of source code and either done a make on it or anything like that? Anybody? So that experience is very consistent with building an actual application artifact. I'm an infrastructure person. I'm a sysadmin by trade. So this is weird for me. And so when I deal with this, I'm like, oh wow, what's going on here? Well, what you're actually doing is you're building an actual application. You're taking a bunch of instructions and you're running a build based on those instructions and creating artifacts at the end of that.
this, take that, copy that out. I'm gonna put my JM lane in there. So now I'm gonna run this in Docker. If I have Docker running, which I do. So again, we're not trying to replace Docker. We're not trying to replace Kubernetes. We're trying to give you a way to get all those applications that are not the low-hanging fruit, that there isn't anything out on Docker Hub for, to have a way to get those into those new environments, right? Because what's the value of just moving half your data center there if you can't get it all, right? And again, I'm not really touching the application. The application in the Node.js application, I'm not really doing anything with it, right? I'm just kind of just packaging up and I'm putting it in different places. But some of the things that you'll see if you go through some of the other tutorials and things that we haven't really touched on is that supervisor process that runs. You can have service groups tied to those. So again, as Ricardo was talking about, like changing port addresses, changing different behaviors from a standpoint of how the application runs without touching the application. You can do those types of things. So you're not doing a rewrite of your application. You're just using those services inside of the supervisor to be able to go and change those specific things. And again, you kind of see here, if I was to run this natively, I still get these same types of warnings and things from the supervisor. So what I'm doing now is I'm basically looking at a supervisor log, and that's the thing that I see. Just like if we have our log4j and our Java logs and everything, we see our server out and server error logs in the J2EE world. I'm looking at the same thing from a supervisor standpoint. I'm looking at this information to see, is my supervisor failing? Are my applications failing? Looking at this type of detail and information to be able to see how my application is running. So now I've got my service running, I believe. And if I go, I should have something here. Yeah, so here. So I'm running version 1.1 of the Habitat Node.js because it goes and picks up my version information. So here's my application running in Docker. So yeah. Let's go back and again, really the thing that you gotta kind of get and understand is that plan file. So if I go and I bring this up and so here I'm defining my package name, package origin, package version. So I've got a dependency here. So I've got a core /node. So if I go out to what's that?
Can you specify a version of a dependency?
So the best way to do that is the version of the application that you're trying to package, right? So if I go and I was playing around with the Splunk forwarder here. So I have Splunk forwarder 7.2.0. That becomes my version information, and that's where that's my version of my habitat plan. So I want to keep in line with that, right? So that way when I'm going through this and when Splunk comes out with 7.3 or 7.2.1, my package version stays the same with that. So that's typically how I would do it for any kind of commercial application.
Tie one of your dependencies, it's all namespace, so core whack node whack version number. And then if you need to tie it to a specific build, you just whack the specific build number.
So, like my particular use case is, let's say we have a whole team that manages all the JBoss, all the middleware type stuff, and they manage all that
They need Java 7.3.2.1. You literally just say, core Java 7/7.3.2.1, and as there are new builds
What's that?
The 1100, which has 3 builds. And the arrow on the right.
Up one more.
No, that one works.
That one's too.
And so see, you can see 2 different point in time builds, because one was built on October 1st and one was built in September 24th. And so if you want to say, hey, we only trust the September 24th build, you can literally tie it to that version of that build. Or you can say, hey, I like 10.11.0.
It's for us, it's usually the other way around. That middleware team says, no, we have to use Java version 2.201, version 1.201,
Yep.
where it is. So then all the operating, basically they'll go upgrade all the operating systems over there, and you have to essentially start consuming the new version. This is kind of like the other way around, where you need to say, hey, I want to consume 201, not,
Yeah.
this middleware team.
I mean, you absolutely are forcing the developers that are working in a specific environment to think about their application backwards. Because rather than yelling at the operations team or the DevOps team that you upgraded we moved from Rel 5 to Rel 8 and now I can't get Java 4 anymore. You're like, okay, I provided you Java 4.
Yeah.
Deal with it.
Yeah, and it's also in the Windows demo that we do, like, so the slides that Lupo had from the, that showed like the legacy slide that he had on there. One of the other demos that we have is actually taking SQL Web Admin tied to SQL Server 2005, which was last updated for 2003, and people tried to get it on Windows 2008 R2 and exploded. We actually have the demo of it running on 2016. Because again, we package all of the old .NET that it needs to be able to run, so we're not relying on the operating system to provide those, because that's a freaking disaster inside of 2016 if you're even able to do it at all. So yeah, this is kind of the example of again, coming from the chef world. Think of this as your supermarket where there's things that are actually out there that are built already. So, if I need core node, like we do with our Node.js application, I just go and say that's a dependency, and then it'll go and download that. And the nice thing is too, it will take all of the dependencies that come along with this as well. So I should have a dependent, yeah. So look at all the transitive dependencies that come along with this, right? So I don't have to worry about that. All I got to do is just get the core node, and then I have everything. Again, we have them out there for Java. We have them out for a lot of the open source software that's available out there.
Full plans now on that site. You could essentially leverage for your application automation.
Yeah, and if you want to help, if you want to be a part of the community, go out there and build this. We have a lot of folks going out there and building hab plans, and they're going and uploading videos and showing really cool stuff of doing high availability with SQL Server, a lot of different things. I honestly, I think this has a lot of value in the Windows world. Certainly it does in the Linux world, but I think there's a lot of people struggling out there with Windows applications and what the hell they're going to do with them. So, learn your PowerShell. So yeah. That's kind of it for the demo, but this is just the very, very tip of the iceberg with this. I mean, we haven't really gone into the hab builder. Builder is again kind of what we're looking at here, of having a little bit of a source control over this and having this. And again, you can put this in a GitHub repo. You don't have to have it published up into the habitat.sh, but again, it's again about the community and being able to share the things that you have with everybody else. So if you go and you build a really kick-ass plan for something, go out there and publish it. So definitely go out, check out hab.sh, and set yourself up a builder site and have at it. Anything else, Dennis?
Also check out our chef route. There's some great videos, about 7 modules out there that take it from A to Z on all different topics around that. They're great videos.
So Dennis is referring to learn.chef.io. So it actually, it has all of our chef, our habitat, and our inspect, which is our compliance as code project, and modules and tracks around those to get you even deeper than even what Jason's taking you right now.
So was anybody to kind of able to follow along, or at least kind of look and see what they're able to do? Again, sorry about the Linux machines.
We'll yell at corporate tomorrow.
Yeah, that's.
It's how you know it's a live demo.
I mean, I even put in there, do not delete in the resource groups of like where it says, oh, hey, if you put in do not delete in the resource group, it's not going to delete it. Nah, it's got deleted. I don't understand how some of these people, there's still stuff out there. If that's the case, then, you know. Maybe it's taking do not, oh, it's got tags, let's delete all of it.
Right. It's the inverse.
Is some of that chef deleted, or?
So we have in Azure, you can set up scripts that'll go and say if this is, if this has been up for a certain amount of time, so I've got time to live, it's got my name and all these different things. So it was like, here are the rules to be able to go and say, have this set up. So in my, we'll get into a little chef here. In my, what do I have this in? So I have so much chef stuff now. Yeah, so in here. Who knows about Test Kitchen? Does everybody know about Test Kitchen? So I have I don't need my Git stuff open. So in my driver here, right, I have all these VM tags. So I have all of these tags in here that say, hey, this is me. I also have time to live. So if I have all of these tags that are supposed to be in here, it's supposed to say, okay, don't reap this VM. Well, I created these this afternoon, tested them, logged into them and everything, and they're gone. So yeah, this is how this works. I created these using Test Kitchen, just kind of looping through here, and then running a couple cookbooks that Lupo had sitting around for installing Docker and Habitat. I can make this available to you too if anybody wants to go and play around with this. This is an easy way to get a Habitat environment. It's on my repo. I don't think I have it set to private, so you can go and download this and play with it as well. Yeah, just for folks who don't know what Test Kitchen is a good way to go and spin up environments to do local development of your chef cookbooks and recipes. It's a way of being able to go and do local development without having to go and go outside of your laptop, because you can run. We have drivers for Docker and for Vagrant and things like that. Typically, a lot of folks know it as Vagrant, but I can actually go and spin up Azure VMs as well using, AWS, GCP, yeah, GCP. Yeah, and also it's not only just for chef stuff too. It's open. It's got Ansible, a whole bunch of different things. So. They're trying to make one for Habitat. I haven't tried it out yet, but this is another good place. Oh, does it? Cool. Yeah, Kitchen CI is where this is as well. Another good place to get started. So you kind of saw a couple different, so Habitat, getting started with Habitat, that's where I'd kind of go out and run that lab, run that test. If you're in the Windows world, there's an advanced one down there as well, if you want to try it on Windows. So yeah, that's kind of it. Any other questions? Any comments? Again, sorry that things got fucked up, but that happens. Yeah. Yeah. When did they turn that on? They turned it on yesterday, right?
Yeah.
I mean, does that mean that I'm the only one that's going out there and doing demos and stuff like that? So. Who's using Azure? I guess so. Anyways, yeah, I guess I probably should. Maybe I should have done it in AWS. But we do have, or in GCP, we do have we do have demos in GCP as well that will go and put. We have another demo for national parks. It's sort of like the same thing that you can go and actually dump it into the Google K8's environment. What's that? I can't remember what it's called. GKE, yeah. So that's it. Thanks, guys, for coming out. Put feedback, whatever you guys want to see. If you guys have things that you want to present, because this isn't just about, a bunch of chef people getting up here and, spewing forth a bunch of crap. But if there's stuff that you want to learn about, or if you want a demo, I've got a guy that's using open source Chef right now, and he's pushing it into Splunk. I'm going to ask him and see if he can come in and talk about this. I think that would be something that's really cool. I'm really, I thought that was pretty cool that he was doing that. So, yeah, I mean, this is for the community. It's not for us, for chefs. So, yeah.
So those of you who subscribe to the Meetup group,